Hello everyone, welcome to my channel Strong Math. Today in this video we will discuss about the derivative of log of sin x by using the first principle of derivative. So let's start. We have to find out the derivative of log of sin x. Here log of base e which is absent. So we are doing the derivative of natural log ln of sin x. You know there are two types of logarithms of two different bases. If log base e a, we write it ln a. This is natural log. When the base is e, then we say that the logarithm is natural log. And if log 10 base a, then we write it log 10 base a. At first we will find out the derivative of the natural log of sin x by applying the first principle of derivative. After that we will check what will be the derivative of log 10 base of sin x. So let's find by applying the first principle of derivative what will be the derivative of log of sin x. Okay, watch the video very carefully till the end. Don't skip the video. Okay, at first let's write the first principle. F dash x is equals to limit h tends to 0 f of x plus h minus f of x divided by h. If this limit exists, then we say that by the first principle of derivative the function, given function is derivable. As the function is derivable, we want to find out the derivative of this function by using first principle of derivative. Okay, so just calculate the limit of this function. Okay, so let's write the functional values. F of x plus h, then this will be log of sin x plus h. You may write ln, natural log, because here the base is e. So let's write ln sin of x plus h minus ln sin of x. Okay, ln means log e base. Log base e is natural log and we write it ln divided by h. This equals to limit h tends to 0 ln. You know that log of a minus log of b is equals to log of a by b. So ln sin x plus h by sin x whole divided by h. Since log a minus log b is equals to log a by b, applying this property of logarithm. Next, limit h tends to 0 1 upon h into ln. Let's we adjust it by adding and subtracting 1 plus sin of x plus h by sin x minus 1. Okay, this equals to limit h tends to 0 1 upon h into ln 1 plus sin of x plus h minus sin x whole divided by sin x. We want to write the limit in the form of logarithmic. That means we want to write limit x tends to 0 log of 1 plus x divided by x equals to 1. We want to write this limit in the form of limit x tends to 0 log of 1 plus x by x equals to 1. So this is our x, ln log of 1 plus x, and we need whole divided by x. Look at the formula. Then we can write the value of this limit will be 1. So here our x is sin of x plus h minus sin of x by sin x. So we have to adjust to make this kind of form. Okay, so let's do that. So to make this limit in the form of limit x tends to 0 log of 1 plus x by x equals to 1, let's adjust limit h tends to 0 1 upon h ln 1 plus, this is our x, so sine of x plus h minus sine x divided by sine x whole divided by this one, so sine of x plus h minus sine x divided by sine x. So this is our extra term, so we have to multiply here to adjust sine of x plus h minus sine x whole divided by sine x. Okay, so limit log of 1 plus this by this term will be 1 by this formula, so we can write limit h tends to 0 1 upon h into limit h tends to 0 ln 1 plus sine x plus h minus sine x divided by sine x whole divided by sine of x plus h minus sine x divided by sine x into limit h tends to 0 this term sine of x plus h minus sine x divided by sine x. Now look, this term is dependent of h, so we have to calculate this one. Now this one by using this formula will be 1 and we have to calculate this limit, so this will be limit h tends to 0 1 upon h into 1 into limit h tends to 0 sine of x plus h minus sine x whole divided by sine x. Now here as a term which is involved with h, we have to calculate at first this one. Here look, sine c minus sine d, we have to apply the formula sine c minus sine d. So let's do that stage. Okay, look at the board very carefully. Now applying the formula sine c minus sine d equals to 2 sine c minus d by 2 into cos c plus d by 2, here we get 2 sine x plus h minus x by 2 into cos x plus h plus x by 2 whole divided by sine x, which gives us limit h tends to 0 1 upon h 2 sine of, cancelling out x and minus x, we have h by 2, okay, and cos 2x plus h by 2 whole divided by sine x. Now look, here the terms involved h are sine h by 2 and cos of 2x plus h by 2. Okay, so we know that another formula of limit x tends to 0 sine x by x equals to 1, right? So here this is sine h by 2, we can take these 2 by h, so we can write it limit h tends to 0 sine of h by 2 by h by 2, this 2 is going to under the h, okay, into limit h tends to 0 cos of 2x plus h by 2 whole divided by sine x. Now we can write 2x plus h by 2 as x plus h by 2, okay, so this becomes cos of x plus h by 2. Now by using this formula limit x tends to 0 sine x by x is 1, so this is 1 into, we can put h equals to 0 here, so this will be cos of x plus 0 divided by sin x, which is simply cos x by sin x. So cos x by sin x, which gives us the value of the f dash x as cot x. So we have the result for fx equals to log of sin x, natural log. The f dash x will be cot x. Now what about the derivative of log 10 base sin x? So now we have the result. If fx equals to natural log sin x, then f dash x will be cot x, and we have log 10 base x is equals to ln x by ln 10, natural log x by natural log 10. So we have to change the base from 10 to the natural log, that is base of e. Now if fx equals to log 10 base sin x, at first we have to change the base to e. So this will be into log 10 base e. Basically this will be ln sin x divided by ln 10. Now if we do the derivative, f dash x will be derivative of natural log sin x is cot x. So this will be cot x. As ln 10 is a constant term, then this will be ln 10 only. So for log 10 base sin x, f dash x will be cot x by natural log 10. So guys, that's it for today's video lecture. I hope you have enjoyed this video. We will discuss some more important and interesting problems like this in our upcoming videos. So till then, keep watching my channel Strong Math. Thank you. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.